Hello and welcome to yet another video. And today we have an X470 Aorus Ultra Gaming from Gigabyte. As you can see right there. This board is very similar to one of the B450s that we had before. Similar to those two boards where one of them just couldn't get fixed, where we had shorted USB-C and a shorted MOSFET, and the other one that was just working. This is from another seller. So I'm very interested, and let's see, maybe this can help me fix the other board. Hopefully this won't be as disastrous as the last one. So let's start with some measurements. So let's start with the usual. We get a ground, and let's go into 12 volts. So on 12 volts we get open line. On 5 volts we have kilo ohms and rising. On 3.3 volts we have around 400 ohms. That's kind of low. Let's see 5 VSB. 5 VSB is high. And PS on also has high resistance. Then let's check the battery. It looks like it has been replaced. Let's see how much voltage we have. 2.6. That's a bad sign if we have 2.6. Okay. So let's see how much current this board takes on this line. It's fluctuating a lot, but around 50 to 60 milliamps. No, way less. That's microamps. That's like 44 microamps. Okay, that is fine. Because I expected already a shorted ITE chip, which still might be possible, but this battery definitely has to be replaced. Let's instantly check some capacitors around this ITE chip, which is one of these sub-IOs, SIOs. If we see any low resistance on them. So the resistances around the SIO or the sub-SIO seem to be fine. Cannot see any capacitor that has like specifically too low of a resistance. So let's continue with the 12 volts. This goes slowly into kilo ohms range. I would expect this to climb faster than this. A little bit odd. Okay, yeah, this is more like it. Okay. This is the... Let's check around the BIOS chips for what 1.8 volt would be. But I think that should be fine. I always just test pins in the corners, and this is ground, probably the fourth one. Okay, but the last one or the first one or the sixth one is or the fifth one, like the one at the top right corner is often the 1.8 volts, sometimes even the very last pin, or sometimes the very first one. Okay, I couldn't find anything interesting so far, so let's see for the passive power consumption and see how this board behaves. So let's see. And we have about 200 milliamps. And interestingly enough, on this board, the LEDs instantly start. In contrary to the other board which we had, where the LEDs wouldn't start with standby. Okay, so 200 milliamps is very fine. Let's get an APU into here. This is the 2200G. Let's put our DDR tester into here. So we have top left CPU, then to the right DRAM, bottom left VGA, bottom right boot. We have the diagnostic LEDs, like we know them. We're first going to keep this battery in here, even though it is drained. But let's just see how this board will behave. Okay, we don't see a proper reaction to the power button, which is very interesting. We have almost no amps drawn so far. So the board seems to be reacting to the power button, but not really. There's no startup sequence or anything happening, really. Let's see if we clear the CMOS. Does this react to that? And it also doesn't seem to react. Let's now get the BIOS battery out of here. Let's clear the CMOS. And after now clearing the CMOS, let's see this again. We get instantly about the 300 milliamps. Let's now push the power button. We just get a very, very slight increase. And we do not go into the power up sequence. This is very interesting. I've never seen something like this before, where it seems to be starting, but not really doing anything at all, because it does react to the power button, but there's no startup sequence, nothing to this. So I would think right now that some of our very early power supplies isn't running. So let's see, is the power PS on signal actually getting onto this board? Because I don't think it is. I don't think PS on is being pulled up here. Let's see if any of my voltages is running. If like the 3.3 volt, as you can see, is not running. So it isn't bringing PS on onto here. What I do is very controversial in these cases. A lot of people don't like when I do that, but I still think it can give you quite some information about the board. Is I short PS on here and see how it reacts and see what it does. So very interesting. I'm currently experimenting a little bit because I didn't know what to do. I unplugged the 12 volt connector, and now we have reaction to the power button. Now we go to 850 milliamps. We have a CPU LED indicator. So I think there might be something wrong with either our SoC line or our VCore line. So let's see. Let's go into resistance mode again and see once more. And now it shows a short circuit. Yup. And now it shows short circuit. This looks very similar to what we had before with 2 ohms. And this is probably the CPU resistance that we have. So probably again a high side MOSFET that is dead. Let me quickly get these heat sinks off of here, and we will have a look at our MOSFETs under there. I've now removed the heatsink, and this heatsink has the very first indication of what is wrong here. So if we look at the heatsink, this is the thermal pad of the heatsink. You can see this, which is solder. And looking at the exact place where that solder came from is this. This MOSFET is pregnant as far as it seems. If you can see this, it has a crack going through it. And yet another MOSFET dead. Interesting. This one might be a little bit harder to remove because there's a big capacitor right next to it. And I do not want that to blow up in my face. So what we will do is we will remove this capacitor first. Let's do that together. So you see, this is the capacitor that I want to remove before desoldering that MOSFET. So what I do to remove that capacitor in an easy way is I get my soldering iron with a huge tip, which is this one here. We get flux onto the capacitor from the back. Then we take our solder, and all what we do is apply it to here, get some nice solder onto both of these pins, trying to get good contact like this, and then just keep rubbing at it, and it's removed. So as you can see, laying there, the capacitor fell right out, and now we can remove that MOSFET without a capacitor next to it. So the big question after this will be, did the other MOSFETs suffer as well? Because as you can see, the one on top of it also has solder pushed out on it. So we're going to remove both of those in one fast swoop. So let's get Flux onto these. So we have enough Flux. Let's remove components. Let's take out the CPU because I still had that in and my RAM. And let's now get our hot air station in here. I'm going to go with probably around 400 degrees, something like that. Going to take my tweezers. And let's start to remove this. It would be way easier to have like preheat or something similar to that to remove these. But just with some time, we will also be able to just heat these off of here. Hopefully, the lower MOSFET isn't welded to the board, but it might be. And we might need to not hot air it off, but we might need to Dremel it partially off. But let's see. So this thing is welded on because as you can see, this already moves, but this one does not want to move. And probably the same will be for the lower one. This one already also moves. This is not as easy. This MOSFET wants to come off with the pad under there. It completely wants to come off with the layer. Okay, we still got it. The layer lifted a little bit, but we got the MOSFET off of there. This is nice because this saves us from a lot of rebuilding. Let's see if the other one, we can do something similar. Yeah, we were able to pry off the other one as well. Whew, that was quite difficult. That was a lot of heat applied in a very short time. And there was a lot of blasting. But we have these two MOSFETs out of here. Let's see if both of these are faulty or only one of them is. So we see our multimeter and source to drain. We have 90 ohms. Pretty sure that is bad. That shouldn't be this low. Let's see, and this is the gate then probably. So to gate it doesn't seem to be a problem, but source to drain is definitely a problem. Like 90 ohms is not what you want to see. Let's check this one. And this one is a straight up short circuit. This is the one that is bulged from the other side. So it was good that we removed both of them. Let's quickly go into the 12 volts and see if we still have a short. And we seem to have kilo ohms and rising. Let's put the CPU into here and see if that resistance still stays the same. So now with the CPU in here, where we before were measuring short. But I am currently in... Oh no. Do we still have a short circuit? And with the CPU installed, we do not have a short circuit. I'm probing the backside right now of the CPU 12 pin. So if we probe this and this, for example, or like here, we have no reading at all. Oh, we have a reading. There it goes, kilo ohms and rising with a CPU installed in here. So I think we are fine on that note. So looking at the general area, we definitely have damage by these MOSFETs that I've welded onto there, but it isn't as bad as I expected it to be. Like, there's definitely, it definitely lifts Like, that is a problem, but it shouldn't be a problem to just solder new MOSFETs back onto here. Because it doesn't seem to be shorting to anything, and it didn't char it into anything. So I don't think that we have... I think we got lucky on this one. So what I want to try really is to actually try to power this on now, because we don't have a short circuit anymore on that phase, or on 12 volts at all. And I would be interested in how this behaves. The big problem is always with the VRM short. There could be also the driver dead that was responsible for that phase. And in a worst case scenario, not only the driver but also the PWM controller could be bad. But let's just find out, I would say. Let's just connect our power to here, see for our passive power consumption, and yeah, find out. So passive power consumption looks like before. And now big reveal, press of a power button. We have CPU, we have DRAM, we have 4 amps. Do we go further than DRAM? I have big hopes for this mainboard, and probably my CPU is burning up right now. We have CPU, DRAM, we are cycling currently 2.6 amps. Let's see if this continues. Let's switch it off for a moment. I hope my VRM doesn't blow up, but it shouldn't, because there isn't too big of a load on here. Let's swap the CPU for a 2200G, not the 3000G, for better compatibility. And put the CPU cooler onto here. Get this onto there. Let's reseat the RAM, because we're struggling on DRAM LED. Let's put it into this slot. Let's try this again. So CPU LED, DRAM, 3.3. Oh, we had VGA right there. That looks very nice. Let's get an HDMI onto here. I'm probably already late for the capture. We might need to restart. But the board is cycling on its own. And we have boot. And there's the picture. Nice. Let's turn it off while our VRM is still taken apart. Oh, that is very good to see. So, yet another case where with missing components, with missing capacitor, and with these two missing MOSFETs, we still get boot out of this thing. This is the frozen image of the BIOS. And yeah, that was what we had. The weird behavior that we saw was because there was a short on the face. And it happened to me yet again that I didn't see the short instantly, because it is a high side MOSFET short. So it only shorts the 12 volts into the CPU phase. What we check by looking into here is if there's a short circuit of a low side MOSFET, because the low side is connected to ground. And there certainly isn't one. So only after installing the CPU we saw the resistance. Only then there was a path to ground from the 1 volt phase, where there's 12 volts at that point. And I think this board was killed by a lot of dust. Like, I think this was filthy around the coolers. And I think this board mainly was killed just by being too dirty. And I've seen this multiple times. I think that, also, if you remember the video where we had a board that had multiple burnt layers through the whole board, it was also filthy. And I had a similar case here, where there's so much dust wrapped around the VRM cooler. And I think it just got too hot. You have a normal load, or you have a high load on this board, and the cooler can't keep up anymore, because it's just clogged with dust and debris and dirt, or whatever it is that collects in their hair and everything. And those act like an insulator and keep the heat in here, and it keeps heating up and getting worse and worse until one of the components has to fail. In this case, it was two high side MOSFETs that failed on here. And as far as it seems right now, the PWM controller survived, and maybe even the double or the driver survived. But we will only know that for certain if we install 2 new MOSFETs onto here. I think I do have them, and if we then check the phases, if they still run correctly. And then we have a whole nother things to do, like we need to check the RAM that it attaches or that it works, gets read onto here, and all of the USB. So we got to a good point, but we have way more to do. Let's continue with cleaning up and finding MOSFETs for this. So after now that we've seen the board post, we now need to replace these 2 MOSFETs. And you might be able to see, but the marking is quite hard to make out. These are 4C10Ns, and what we have here is 4C10Ns. Even the focus is, yeah, there we go. So I have new ones of these. These seem to fail quite often because I've already taken 3 of those, and I've taken some of those off of donor boards as well. So let's replace these 2 onto there, and we will see if that fixes our problem. So we still don't know if anything else suffered, like the driver controller that you have down there, or it might be the upper one right there. If those have failed, or maybe these 2.2 ohm resistors like to fail also that are connected to the gates. But we will find out. We will be soldering onto here the MOSFETs, and also because the board has lifted, as you've seen before. But what we're first going to do is we will put some solder onto there, some leaded solder, to lower our melting temperature so we don't have to use too much heat. And now with applied leaded solder, let's get new MOSFETs into here and hot air them on. So my hot air is set up to 400 degrees. So I gotta say, these were pretty hard to put down. The board was fighting me quite a lot with the lifted up traces. So what we're going to do is I will want to make sure that these are soldered on, and I will be using my soldering iron and going to be applying some more solder from these sides just to be very sure that these work properly and have good enough contact, because the big part of cooling of MOSFETs happens through touching the solder points. So through the solder points, a lot of heat is also being dissipated. And we want to make sure that they have good contact and can dissipate a lot of heat, so something like this doesn't happen again, where they're probably overheated and then shorted. So I've tried now. I think it worked, but we will see as soon as we now going to be trying to start this board up, how it will react, if the phase is actually going to run, and if we're going to have post here. So now I've cleaned the area up. And now what we're going to do is we're going to start it up. I'm not going to populate the capacitor yet, in case we need to do some soldering here again, maybe with the driver. But we're going to try to start it up again, see if that phase is running. And yeah, and go from there. So the board is assembled. Let's now see together. We have 250 milliamps of power consumption, of passive power consumption, which is alright for this board. And let's press the power button together. And this looks very promising. Going to VGA and rebooting. Power consumption is jumping just like we wanted to. The LEDs are jumping. Currently on DRAM, VGA. Let's see if I get an indication on my keyboard. The VRM seems very cold. That's very good. And I have indication on my keyboard that we are up and running. And I have a picture, but you can't see it right now. Something's probably up with my post screen again. But just trust me that we do have picture right now. At least trust the numlock indication of the keyboard. And let's start the board once more together. I've mostly built it up now. Just the CPU cooler needs to be probably put on here, and we get a pretty fast boot screen because I now also have the CMOS battery in here and it doesn't have to reset every time. We have a GPU in here, we get post through the PCIe slot, and I will now populate the RAM modules, put a proper heatsink onto here, and we will do some stress tests. And now our board is up and running. We have 4 DIMMs of RAM in here. You can't see that. We have 4 DIMMs of RAM, we have the cooler on here, we have some Ethernet connected with USB devices, we have the graphics card. And what I will do now, I will run a stress test for stressing the CPU and especially stressing the VRM with the LINPACK, and we will see if that does what it needs to. I roughly know how the results should be of the benchmark, and I will compare that and get you back as soon as that is done. And we can see LINPACK has passed, and the time is according to what I would expect. So I suspect that the VRM is fully working now and that we don't have a problem with that anymore. I will now test the GPU. We will run Unigine Heaven and see you then. And with that, Unigine Heaven has also passed without any problems. And with that, our fix comes to an end. This mainboard is now working, as you can see by the post screen there, up there. And the board is still working right here on the desk in front of me, as you can see. I hope you enjoyed the video. Hope you enjoyed the repair. You learned something in this video. And luckily this time we got the Gigabyte board fixed. I was really afraid that we're going to have something similar to what we had before with the board that I wasn't able to fix. But yeah, we got lucky on this one. The VRM didn't blow through the whole board like we had it before on an ASRock board. And it was easy to fix. So, this was Mainboard Medic. Thank you very much and goodbye.